In this video, we're going to talk about force field and shadowing in HiPhyEngine. We're going to start with a scene already have two pieces of clouds modeled. So if you simulate this, you can see the one piece of clouds is moving and the other one is stationary. You can try to set up the simulation yourself, or I will link the files below. But it will help us just starting with the force field. So to add a force field in HiPhyEngine can be any mesh object. The reason for they need to be mesh is because they have to be for visualization. And we're just going to use a cube here. And this is our previous force field. Ignore that. We're going to name it force field new. Okay. So if you go to the HiPhyEngine panel, and you can see the force field here. And if you choose it, and by default, the force field in HiPhyEngine uses expression and specific SE expert expression. You can find documentations on SE expert expressions on the website, and I will link it as well. It's very simple language, but I'll give you a lot of controls. So right now, what we support is you can change time and position. So if you look at the expression, it is a sign field that changes with the position and time. So essentially, with the time moves, the wind field changes with time and position. To visualizing it, you just need to update visualization mesh, and it will convert the existing mesh into a vector field, so you can see it. And if you turn on the live update, and you can see how the wind field is changing with time and also position. You see different position now have different force. And again, the visualizations on, even though the visualization is very small on patch, the force field actually exists everywhere in the scene. And to apply the force field to simulation objects, you need to add the simulation objects to the force field. So we're going to add the two cloth object on it, and you also need to set the solver in this case. So that's about it. You can see that you can control the force field weight on each object, and there's a multiplier. The multiplier is just for simplicity, so you can have something that's almost unit length, and then using the multiplier to scale up the force. So we're just going to keep it on 1 here, and you can control the weight of each object so they receive more or less. And if we run the simulation now, you can see the wind field is blowing. And because it's very erratic, so you can see that it's moving the cloth forward and back because we have a sine field. All right. So that's the force field, and yeah, it's just gonna wave slightly forward and back because of that. So let's change the force field to something simple. So we're just going to have, let me see, this is the x direction, so we'll just have the -1, 0, and 0. And 0, okay. Updates. So now we just have a force field on pushing into the first cloth. So in real world, you imagine that the first cloth should block the wind of the second cloth if it's right in front of it. But right now, if we're running the simulation, you will see that it will not happen. The wind fields, because it exists everywhere, you're gonna pass through directly applied to the second. So this is why the shadowing comes in. So you can see that. Let me increasing the force field multiplier to 2 so the wind is more obvious. How HiPhyEngine emulates the wind being blocked is what we call shadowing. So you can see, if you select a simulation object, you can see the shadows effects here. It separates out the shadow distance of simulation objects and shadowing distance of the collision object. So how shadowing works is when the wind hits and points in the scene, and what it does on the simulation object, what it does is going to cast the ray along the force direction to see if anything blocking it based on the distance. So if it's something really far away, you imagine you will not be blocking it, but if something pretty close, you can block it. And it does separate out the collision object from the simulation object, so you can control them separately. And for this thing, we're just going to set something really big, even though it's only 2, but we're going to set a big number, so it's always being blocked. There it goes. Now the 2 has more obvious effect. And then you can set the effect of it. So right now, when it's 1, means all the forces will be blocked. So when the plane, when the cloth in the front is blocking the one in the back will not feel any of the force field. If you set something like 0.5, you only feel half of it. So that gives you some more control over how much force is being shadowed. So now if we run the simulation again, okay, and see, only the front one is moving because the back one is being blocked. But once it's been moved away, give it a little moment, 20th frame, there it goes. Once it clears, the back started feeling the force because now it's clear of the shadow. So yeah, that's it. It's very simple to set up, but it's very powerful. Allows you to create some effect that's if you have a cape, then if the wind is blowing in the front, the cape should not be feeling as much wind. So give you that illusion of wind being blocked. Before we leave, just a quick note. The expression supports some parameters. So if you look at the default value, let me reset this to default. Right now, we only support $P and $time. So $P is the position. So the position is actually in the force field space. But because I have visualization, so you can see it pretty clearly. But this $P is in the force field space, not the world space. And $time is just the time that the simulation time. So it's actually not it's not the scene time, it's actually simulation time, because in the solver you can see there is a time scale. Effectively, you can scale the time to slow down the scene as if in slow motion, and the $T will be the simulation time, not the scene time. The reason for that is the force field had to be computed inside the simulator as well, and they must match the scene time, and the simulator only knows the simulator time. So yeah, that's it. The expression only supports position and time right now. We might add more support right now in the future, but we don't know whether velocity or other parameters is important for force field yet. So yeah, that's about it. See you next one.